conservation and environmental modeling for flood and water resources management, more in the context of global climate change. Day before, we had a session on vulnerability mapping, risk analysis of sand and dust storm. And prior to that, we also had a session on ecosystem health, drought, flood monitoring, early warning preparedness and response. So you see, each session has been quite unique, and today our focus is more on water resources management. And for this session, I requested David Stevens to be moderator of this session. The reason being, there are two important reasons. One is when UN Spider was in its conceptual stage within UN office, UN OSA, United Nations Office for Outer Space Affairs, David Stevens was the one was driving entire initiative of formulating UN Spider. In a way, UN Spider is his baby, and he was part of our team. We worked together almost like 7-8 years, and then he moved to United Nations Office for Disaster Risk Reduction, and there he was involved in SENDAI Framework monitoring. So I found none better than him to moderate this particular session. So this is my introductory word about David. He will take over, but before that, I give word to Fatemeh from Iran. Over to you, Fatemeh. We cannot hear you. Is it mute?
David should unmute himself.
Yeah.
No, I'm unmuting myself. I thought Fatemeh was going to talk.
Excuse me?
Yes, now you're audible, yeah.
Again, good morning, good afternoon, ladies and gentlemen. It is so nice to have you again here in the third, or better say the last day of our workshop. I should welcome you all back to our sessions. Of course, we are gonna start session 5, which is Geoinformatics application in water resources management challenges and opportunities. Our first speaker will be Mr. David Stevens, and it's a good thing we've got him also as the moderator of this session. I think Dr. Shirish has introduced him very well. I thank you, Doctor, and Mr. David Stevens, please go ahead.
Good morning, everyone. Thank you, Fatemeh. Thank you, Shirish. Good to be here. Good to be back. Fortunately, not in Tehran. I'm trying to remember the last time I was in Tehran. It must have been at least 12 years ago. In fact, I think one of the first workshops UN Spider ever organized was in Tehran, 2007. So there's a long history of working together with the Iranian Space Agency.
Hope to see you, Doctor, here again.
No, I have to go back, but to visit. I have to go back as a tourist. When I got the news of the workshop, I was very interested in participating because to me, I think it's key what data has as an impact on building resilience worldwide. And I actually wanted to give a presentation. That's why I suggested, and Shirish kindly put me in to set the tone for this presentation. We're going to talk about water. Water to me is one of the key sectors in building resilience across the board. Ultimately, we're at the decade of action. So I've actually got a small presentation I put together. I've asked all my speakers to stick to 12 minutes. So let me put it up, share the screen. There it is. Hopefully it'll go up. And you should all be seeing the presentation, correct?
Perfect.
Perfect. I wanted to talk a bit, sort of fall back and say, ultimately, if we're not impacting, if we're not creating what I call risk-centered, climate-sensitive development, we're not doing our job. And I say this because we've reached a point where, you know, we're not going to run away from development, but it has to be risk-centered, and more it has to be climate-sensitive. I mean, we've got to avoid what we're seeing, particularly this year in terms of the fire. So this is just a focus. And I wanted to sort of talk about the global frameworks in place, because each one of us, as we work in our local solutions and developing our technical systems, we have to be able to consider what governments are already agreed to and what they're working in silos, but what we as experts should be helping bring everything together. This is what the space community's perspective see, and I always like to sort of say we have the wider perspective, but the fact is our end users have a day-to-day, I mean, they live with this reality. So we've kind of got we have to bring these two realities together. We have to bring the strength of what we have in terms of geospatial data down to solve these sort of problems. And not just solving the problems by coming in with remote sensing and, you know, after the problem has happened. And I took this news out of the Washington Post a couple of weeks ago, which shows that people are still moving into flood zones. I mean, we've still got people, even after all these years of being alerted to the problem, you know, and this is only going to get worse because of climate change. So some of the points I want to consider stressing through this sort of introductory presentation is we need to ensure that we are de facto contributing to the better decision making. We just can't make beautiful studies. We can't just sort of say this satellite works for this. We've got to say we're actually getting the decision maker to optimize his decision based on what the policies request. And we have to build on top of the international policies. Everyone here has to know which are these international policies, because these international policies and legal frameworks, they replicate within the countries in some of the key development plans which are being developed. Earth observation data is just one piece of the puzzle. I mean, data, governance, community, they're all important, but data is only one of them. And you have to be part of the solution. For those who know me, I always like to say this, and there's a Kenneth Boulding statement said, the world moves into the future as a result of decision, not as a result of plans. So I challenge everyone here working with geospatial data to actually look and see, are you improving, making better decisions? And these are the decisions which have to fall within the international frameworks. And you all have to be familiar that we've got a number of international frameworks, but we've got some of the three main ones. One focusing on disaster risk reduction. So that's, and it's been going on since the 80s with the International Decade for Natural Disaster Reduction, but it culminated in 2015 with the SENDAI Framework. And at the same time, we've got the 2030 Development Agenda, the SDGs, and the Paris Agreement. So all these happened in 2015, and it's interesting. In 2015, we had these three major agreements in place. The top picture is SENDAI. SENDAI was the first one to be approved. It's interesting. Disaster risk reduction is something which is very important, but it was difficult to approve because the language in the disaster risk reduction framework sort of replicated into the Paris Agreement and SDGs. So in a way, the three agreements tied together. In practice, at the local level, we haven't managed to implement them in a coherent way. Something to have in mind with the SENDAI framework, it built on top of the Hyogo framework, and it actually set a target of a substantial reduction of disaster risk and losses. So it says we are definitely going to reduce disaster risk and losses, and it set 7 global targets. So you have to be familiar with these global targets, because in the disaster risk reduction community, this is what the countries are working with. So you've got four targets which reduce deaths, affected people, economic loss, and damage to services and infrastructure. You got the important target E, which is the national and local disaster risk strategies. And then you've got targets F and target G, one focusing on international cooperation and international funding. And the other one, target G, are the multi-hazard early warning systems. So when you're looking at DRR, when you're looking in the countries at the national and local level, they have to be working on that. Providing what we call a SENDAI Framework disaster reduction perspective. Key things happen in SENDAI, building on top of the Hyogo, but I think the most important one, if you look at the text of SENDAI, it says it focuses on risk, current and future. So when you're planning something in a country, you're not looking at the current risk, you're looking also at the future risk, not of only what you're implementing, but what's around you. And we all know that climate change is the big driver of future risk. So in a way, the SENDAI framework brought us much closer to the Paris Agreement, because we're now, as DRR experts, focusing on future risks. and a number of other things as well, which is SENDAI Framework. But more importantly, it provides a responsibility across all stakeholders, each and every one of us, even though the implementation of the SENDAI Framework is done by member states. I just want to highlight target E, which is the most important one, is that countries have to have national and local disaster risk strategies. And a number of countries do. We have over 120 countries already with their national and local risk reduction strategies. That's a huge number as compared previously. And so countries now are going back to these national strategies, which they produce, and they're having to revisit their risk assessment, because risk is key. I mean, you really have to understand the risk which you're involved. I always like to say this, and you've heard this a lot, disasters are not natural. Disasters don't happen because there was an act of God. I mean, when you have people living in such conditions, it's going to be a disaster. And as a society, we actually accept that people living in such an acceptable risk is business as usual. So in a way, what is our risk perception? What is an acceptable risk? And it's interesting, I worked in Brazil. Well, I'm actually Brazilian, but I was in Brazil with the UNDR office in Brazil. And I used to ask mayors, what would be an acceptable number of deaths in your city within the next year? And they would all say 0. Well, I'm sorry, it doesn't happen 0. With disasters, you're always going to have that. You have to balance what is it you can do. So you look at historically, you're going to have a few people die every year, floods and fires and even car accidents, although you might question whether car accident is a disaster, but that's bad engineering. What is an acceptable risk? As a decision maker, you've got to look at your problem, you've got to know your risk, and you've got to make a decision. Sorry, this slide is actually out of place because I wanted to put it before when I talked about risk. Remember I said we live over constant risk, but we're not aware of the risk. Hurricane Irma in 2019, just after the hurricane came by, people started buying in Miami. They took advantage of the price went down and buying. People don't have a perception of risk. And this is a news, recent news, just a couple of years ago, where areas like Miami, most of Rio de Janeiro, many cities, they'll be under water in 80 years' time. Or if not underwater, they'll be suffering the impact of high tides. And yet people just continue buying there. Okay, sorry for that. That slide was out of place. It should have been before. We go back to the risk, focusing on risk, where you ask a mayor, what is the risk? And this is where we have to do. We have to actually help countries look at how they're assessing their risk. And based on their risk, they're doing the national DRR strategies. And there's basically 4 strategies. You either reduce the risk, you retain the risk, you transfer the risk, or there's a risk which you just can't avoid, and that's called the residual risk. Okay, this is an interesting thing, and I could give you a whole hour just on that. But when you're looking at your problem, you've got to decide the problem you're trying to solve. Is it a risk reduction? Is it a risk retention, a risk transfer, or is it a residual risk? Risk reduction is the easy one. It's when you have a contention wall, or when you're removing people from flooded areas. You're taking out communities in flooded areas. So basically, you're taking the people out of harm's way. You're retrofitting your building it. Retention is when you have a financial reserve. So if someone's house is flooded, you basically you provide them a time to you give them a temporary shelter. Risk transfer are the insurances, and insurance companies love that because everybody buys an insurance premium and you don't have to worry about it. And the residual risk is the more important one. It's the risk that you just cannot do anything about. It's like the Indian Ocean tsunami in 2014. It's like the current COVID-19 pandemic. And it's also regarding climate change, what's going to happen to the Pacific Islands. So when you're looking at your problem, you're looking at risk, you have to decide, so this is something you should develop your consideration for. This slide was presented on the first day. It's just important that it goes back to the idea that within all the agendas, everything is tied together. There's reference of the SDGs in SENDAI, there's reference of climate change in SENDAI. Everything's tied together in the frameworks. Are they tied together when you're implementing? When you're solving your water management problem, when you're solving your food security problem, are you considering all 3 agendas? Are you considering the 17 goals of the Sustainable Development Goals? Are you considering the fact that climate change is a driver of risk? I mean, we got the new IPCC report this week, which actually is very negative because it says basically there's nothing more we can do regarding the 1.5 degree increase. And you've got the Paris Agreement. And interesting, in the Paris Agreement, when you're looking at it, you've got two areas where you can contribute to. One is on the mitigation of the greenhouse gases, where you're actually trying to take away the greenhouse gases. And another one is the adaptation and loss and damage, where countries have to come up with national adaptation plans. Now you've got the national adaptation plans, and countries have a guide to developing these national adaptation plans. And you've also got the national risk reduction strategy, disaster risk strategies. These have to be talking together. So when you're working of a problem of water management, you've got to look, well, how does the water management considered in the national adaptation plan? How is it considered in the national risk reduction strategy? And my last slide is exactly that. UNDR has just finalized a document which actually looks at how you can ensure that your work with the national strategy is aligned with the national adaptation plans. And this is something you have to consider. And there's one last slide here, which I won't go into details, but it basically says about the benefits of ensuring the coherence between climate change and DRR. So I hope I sort of set the tone. I always do that. From a policy perspective, the world has advanced tremendously since 2015 in having these international frameworks. We do know there are the silos in the countries. When you're in the country, the climate change people don't talk to the DR people, but we as experts have to ensure that at least in the solutions we consider, how can we build a better risk-informed solution to what we're dealing with. And with that, that's my short introduction, and let me cease presenting, stop sharing. And then I have the distinguished presenters, which I have asked everyone if we can keep to 12 minutes so that we can have at least some time to answer some of the questions. Please do put your questions into the chat box. Take advantage of any link there, because I've asked also, let's keep the links, because the important thing about a workshop like this is we get ideas and we get network and we actually get to meet each other virtually and learn from each other. So with that, I would like to hand over to Ms. Sarah Atachi from the University of Tehran, who's going to talk about something which I'm very fond of, which is comes from the multitude of space-based sensors we have, and Sentinel, of course, has given us an incredible opportunity here of data to help us with all the area, including flood. Mr. Tachi, please, you have the floor. Over to you.
Hello everybody, and good morning. I hope you're hearing me well. Thanks for the nice presentation and also for the introduction to my presentation. Today I will speak about the contribution of the Sentinel-1 time series images, especially for the flood mapping. We have already know that there are many satellites provides images over the air surface. But I will emphasize today on one of the mostly new one, and it has really give us freely based available data. So, and it's one case study in the north of Iran. Next slide, please. So the title of the presentation is the Sentinel-1 time series for flood mapping, a case study in the north of Iran. And you can see it was really huge flood, and even the streets was full of water, and people used the boat for the transportation. So we'll go through the presentation. Next, please. So we have already know that flood is one of the most destructive natural disasters, and we have these severe flood events almost in many parts of the world. Even we can see last month we had the severe flood event in the west of Germany that more than 100 people were killed. So it is still important that we can detect the flood affected area, because the lives of many people are threatened by the floods. And in March 2019, 2 years ago, a severe flood occurred in the north of Iran. And it was not the only one that happens. Actually, we had these severe floods in many parts of the country. But the interesting part was that this flood was lasted for 2 months in the city and in the agricultural land around the city. Next, please. So the case study that we have chosen is a city. You can see in the left picture, it shows the place in the Iran. So it is near the Caspian Sea, and we can see the Sentinel-2 images, the RGB color of Sentinel-2 images. And in this area, we have the city, we have agricultural land, water reservoir, and lakes, and all of them was full of water during the flood. And the idea is that how we can monitor this flood, how we can detect the flooded area by use of the Sentinel-1 images. Please, next slide. What was interesting about this region was that this region is, we could say, this semi-arid, and as you can see, the average monthly precipitation is very low. And if we compare March in 2019 with the other months, it can see that it is much more higher. And if we want to compare this amount of precipitation, if we look at the yearly average over the 10 years, next please. Oh, here we can see the average annual precipitation from 2010 to 2019, and at the if you look at the bottom of the slides, according to the IRIMO, Iran Meteorological Organization, this amount of precipitation was about 200 millimeters higher than average, the 10-year average and 20-year average. So it means that we have really severe precipitation amounts during a very short time. So that was the main cause of the flood. So it is too much precipitation in some very few days. Next, please. So the interesting thing about this area is that this area is totally flat, and you can see the elevation map and even the slope map. We have even the elevation below the sea mean level, so it means that okay, the area was even under the average height. So, and that was the reason that the water lasted for more than around 2 months in the city. And next, please. So here as I have already said in introduction, I wanted to emphasize on the usage of the SAR images. We know we have already known Landsat images or other type of spaceborne images like a spot and so on. Both all of them works in the optical range of electromagnetic spectrum. It means that they are affected by the humidity and cloud cover. So when there is like such a severe precipitation amount, it means that there is cloud in the cover in the sky, and then this cloud is like blocks everything. So we cannot, the electromagnetic wave or optical wavelengths cannot penetrate through the clouds. But when we have a longer wavelengths, so it means that in the like SAR images, in the radar images, they can penetrate through the closed atmosphere, seems transparent to them, and then SAR images can contain unique information in such an area when there is a cloud persistent, when the optical images actually fails. In the next slide, please, next. So as I've already introduced, we know that Sentinel-1 belongs to the mission that is started from 2014, and it provides us a very, we could say, medium spatial resolution to high spatial resolution around 10 meters, which is quite good for the Earth observation. And it provides even the dual polarization. But what is interesting for these images is that the mission, according to the protocol, so it's free of charge, and it's also it's also free on the internet, and it's freely available. So it means we can access to the full archive of the data, and then when there is such an event that we cannot go to the classical Landsat images, Sentinel-1 images can be a good substitute for that. So the importance of this study is that we only lay on the Sentinel-1 on the SAR images, and we do not use the optical images. So please go to the next slide, and we can see the flow chart, I think. Okay, here is the data set according to show the what was the changes during the flooded area. We take like 8 images pre-flood, during the flood, and post-flood events, and you can see that all of the images were in the same processing level, but it starts from the mid of the March to the 1st of the June. Sorry, next slide. And here is the multi-temporal Sentinel-1 images. So when we have the SAR images, it means every pixel contains the backscattering values. And as we know that the backscattering values of water differs from the other land covers. So we have different scattering mechanisms. So based on these backscattering changes, we can detect flooded area from non-flooded area. Next, please. So as Sentinel-1 images really needs a very big data processing tools, because they are very, they need like a large capacity computer. So it is important that we know that, okay, on the local laptop we cannot, or local computer, we cannot really process them. So we use the Google Earth Engine, which is also is like a cloud platform, and it could be easily accessed and process the satellite images. So this research is based on the Google Earth Engine platform. Next, please. And here is the flow chart. So it seems simple. So after we acquire, or we just retrieve the images from the internet and pre-processing, we use an automatic thresholding method. So we use one of the mostly used thresholding method, which is auto methods, and it just uses the histogram of the images to separate water from other remaining lands. And it means that after that we have the map of the flooded area, because the backscattering value or the behavior of the flooded area in the radar wavelengths of electromagnetic spectrum differs from the other lands. Next, please. So here is a detected flooded area, and we can see that, okay, where we have the water reservoir here, when there was no water, there was no flood, and then it was all of the next 6 slides is from during the flood, and the other one is the after the flood event. And we just make an accuracy assessment with some natural reports. So we really achieved a high accuracy. Next, please. And here shows the extent of the flooded area. So we can see that, okay, the extent of the flooded area really changes during the flood as we expected. And what is actually I said is that the water remains in the area. And next, please. So here shows the percentage of flooded area at different elevation and slopes. So we really expect that when we have the lower elevation or lower slope, so we have the flooded area, or concentrate on that area. And the next one. And here it shows a different part of the study area. As we can see in the last row, is a histogram of the images. So when we want to use the thresholding method, and it is like automatic, we need a bimodal histogram. So it means that we have 2 peaks in the histogram. So there should be a threshold, a line to separate water from other remaining land, and the backscattering of water is always, we could say that, lower than the other. So it's like the basic how this thresholding algorithm separate water from non-water area. And the next slide. So it's my last slide. So we really here emphasize on the exploitation of sentinel-1 images. So it's important that we have the archive from the 2014, and it will be continuous. So it's really give us a good opportunity to concentrate on that and to use it more and more. And I think the spatial and temporal resolution really make it suitable for time flood mapping, which is very important when we want to serve the lives of the people or to organize other kind of the help. This research also was published in an environmental monitoring and assessment. I try to keep this 12 minutes. I'm here if we have some question or feedbacks, or we can use the meeting chat. Thank you for your attention. I'm done, David.
Thank you, Natasha, and thanks for keeping the 12 minutes. It's very interesting. Interesting. I haven't used the Google Earth engine, and I'm wondering, this is something I've got to go back and learn. So thank you very much.
You're welcome.
In terms of the research, how do you move into making this, integrate that into urban planning? I mean, have there been any questions about using these methodologies to support urban policies, for example? I'd be interested to see that whole idea that you've actually you're developing a solution, you're coming up with results, you're showing people the impact of the flooded areas, and how can that actually influence decision makers, mayors who what is the follow-up to the research currently?
So what is really was interesting, it was shows that, okay, you can see that even the city was flooded by the water. And this was happened when there was, it was more because of the elevation, I think. But it just shows that, okay, when they want to plan for the maybe new area, because many of the houses really were damaged. So it means that we should not go for the area that are prone to the flood. So even they should consider it in the extent or if the development plan of the city, I think. And we had actually some people were killed just because where the houses were built is not in a maybe correct place. So.
Okay, very, very, very interesting, and definitely something I personally have to learn. I've been out of, I haven't processed an image for many years, but I think it's something I probably wouldn't mind going back and learning more about Google Earth Engine. Thank you very much, and I'm sure there'll be more questions. My idea would be we could go on to the next presentation. Mr. Funmilola Olufafemi, you have you have the next presentation. From Nasra, and it's been, once again, been many years since I've been to Abuja, in a new place, and I'm really looking forward. We're going to talk now, building on top of water, but more from the perspective of the water sector as a whole. So I'm very interested in your presentation, building a higher perspective in terms of what we're looking at water and how space technologies can contribute to that. So, Ms. Olufafemi, you have the floor, all yours.
Okay, thank you very much. I appreciate being here in this workshop at this time. Thank you once again. I'm Funmilola Olufafemi from the Space Agency of Nigeria, and I'm a scientific officer in the Space Agency of Nigeria, and I'm making a presentation on improving the water sector through space technology for water resource management. The next slide, please. Yeah, we have been talking about water in this workshop, and water is a common good. It is useful now and also useful for the coming generation. Therefore, it needs to be used in a sustainable way. It needs to be preserved and managed properly. And this actually puts the water sector at the center of it all. They are the center of it because water is under pressure from a variety of areas. Is it for industrial production, in health, hydropower, water supply and sanitation, for agricultural purposes, for suburban development, and also in the area of climate change, because increase in the frequency of flooding and drought affects climate change. Therefore, water resource management plan is very, very important. Inappropriate water management can deplete water sources, pollute water systems, contribute to soil infertility, erosion, and destroy natural ecosystems. Therefore, water resource management is very, very important. An important challenge confronting water management is to improve water use efficiency and its sustainability, and this will be met by how to utilize the timely, objective, and accurate information. The next slide, please. So there have challenges of the water sectors in the developing nations, especially. And some of them, they are listed here: how to supply and utilize water in the nation, how to establish the means to acquire, collate, manage, and disseminate hydrological, hydrometeorological, and hydrogeological information, how to ensure easy accessibility of supply of water to all nations, how to reduce the population of surface and groundwater, how to ascertain the nature and level of investment, and then, of course, power generation potentials of dams and the challenges of health rule of water. But to also note that there are also other emerging challenges that should be looked out for. They are very important. That's urbanization, people moving from the rural area to the urban centers, growth in population, funding gaps, policy inconsistency, and operations and maintenance. Next slide, please. The application of space-based technology to the water sector for water management. Of course, space-based technology is very, very important to the water sector, and there are technologies that are developed by space science or the aerospace industry. Space-based technology makes it possible to view from far above water trends of a nation or region, addressing challenges on a global scale. And geographic information system and remote sensing, they are space-based technologies. Remote sensing satellites are also called Earth observation satellites, and they have sensors to collect data in the form of images and provide specialized capabilities for manipulating, analyzing, and visualizing those images. GIS are able to bring large amounts of data of both the physical and social system together in one comprehensive overview shown digitally. Therefore, remote sensing is highly useful in the water sector for water resource management. Next slide, please. Yeah, so there are so many benefits of space technology for water management, so important. Utilization of the space-based data and technology can address water protection, use, and management by they facilitate, improve, monitor, and also reports in relation to sustainable development use of water. of water. And space technology can address current issues and challenges related to water management domain, identify gaps, and can contribute to better management of water resources in general. They are also able to, there are researches that can be done related to mountain region-specific water challenges, combating desertification, water storage, floods, droughts, monitoring, ensuring access to safe drinking water, and managing water-related emergencies, and so many benefits, and also prevention of disasters such as flooding on the farmland. And important area is also research on the microplastics in water bodies. The use of space technology in this area is emerging. This is because microplastics, they are so tiny that the fishes inside the water bodies, they take it up, and humans are at the end of the food chain. Humans also eat it up, and then causing so many negative effects in the human bodies. So the benefits of space technology for water management is quite important. Next slide, please. Next slide. Okay. GIS and remote sensing, they are important tools for the water sector. It has been said over and over that remote sensing survey from the space, and therefore able to have solutions on a global scale also. But remote sensing for the water sector is a research tool that is rarely applied for water management. Therefore, the water sector, they have been encouraged now, especially the water sector in the developing nations. So many people look at it as a specialized research tool, that is not for everyone. But it's actually an important asset for water resource management, and it's becoming more user-friendly, more accessible to more people of different discipline, and now more understandable, and the knowledge transferable to water resources management. And it's also good to note quite well that developing nations are quite often unaware of the new technical possibilities on GIS and remote sensing, because the discussions or the images on remote sensing remains within the remote sensing community in the space organization or the space agencies, making the data to remain underutilized by practicing water resource managers. Next slide, please. Yeah, so the importance of water professionals or water management experts. The water professionals, they have problem-oriented researchers in the knowledge of water quality management and protection. So the national water management is not likely to work without water professionals or water management experts. The water sectors of the developing nations, especially, most of them are not competent. They are not competent because they are not trained well, or they are not given the required capacity building needed for their work. So it is quite important that they are trained. So competent water professionals in the water sector, they are highly important. Next slide, please. So there is a need for the collaboration of organizations researching in relation to water and space. This bridge needs to be filled, bridging the researchers, practitioners gap. is very, very important. So the collaboration of organizations researching in relation to water and space, we allow the management of water resources by sharing data from research done and bringing about demonstration projects. Next slide, please. So goal 4 of the SDG is quality education, and goal 6, clean water and sanitation. We have been talking about today the clean water, linking it with sanitation. But the goal 4 is about quality education, and it's still buttressed down to educating people about the water, about water sector, what they do, making the water professionals to be competent, and also bringing about catching them young platform for the children, bringing them into the water sector, letting them to know on time there is something to be done in the water sector on how to manage water sustainably for the coming generation. Next slide, please. In conclusion, the applications and benefits of GIS and remote sensing expand far beyond space. They are important assets for water resources management. Current water professionals and water management experts can have capacity building to aid their work and career in relation to space-based technology to enhance water management. There should be collaborations among water and space organizations to enhance water management efficiencies in the water sector. In whole, if GIS and remote sensing are critically applied in the water sectors of developing nations especially, it will target the 3 pillars of sustainability, economic development, environmental protection, and social equity. Next slide, please. Thank you very much. This is for your further reading, and thanks for your active attention.
Thanks, Fumilola, for the presentation, and particularly for bringing this very close to something which I think is so important. The fact that when you're looking at water, you have to look from a perspective of all the agendas, and you brought SDG goals 4 and 6 closely together to the work. And it's something we've been discussing. If you look at some of the DRR things, everything is a systems approach. You can't have sort of an individual approach. I mean, everything is interlinked. Bringing it to the COVID crisis right now, it's becoming a food security crisis now. So you begin with a health crisis and ends up with food security. So I don't see any question, but I do have one question. Something which always comes to my mind is that we as technical experts, and I still consider myself a technical expert besides so many years in the UN. Question is, the tools are only as important if they get used. And I'm thinking, yes, you permeated quite well that we have to build the capacity so people to use the tools. But how do they actually get used on an everyday basis? When does it become so? Beyond building capacity, what is it we can do to get people to actually use the technology? Have you thought of that in terms of that? I'll give you one example, Google Maps. I mean, I'm still from the generation where I used to drive around in my car with a paper map. I don't think there's anybody who buys a paper map anymore. You don't, you have your Google Map. So it's interesting, that is a tool that all of a sudden became very used. And I'm sort of wondering, at one point, when is it we will have on our mobiles Sentinel data, Google Earth Engine, and all of a sudden at real time process the data and decide how to go home. So I think it's more of a challenging question, but particularly as you were looking at the water sector from across the agendas, which I thought was very interesting, and a lot of those slides are things I personally will go back to. So how can we get people to use more of the technology to support the water sector, the water management sector? What's your thought?
Okay, yes, what we need to do is to keep enlightening them. to keep enlightening people, and then we can also come up with training the trainers mechanism. That's taking some specific people, maybe in the water sector, training them intensely. If it's taking them to another country to be trained, and then they come back to their home country and then train others. So when this mechanism is continual, and then people will be getting enlightened, and then also getting more use to this technology. Oh, sorry, I'm not hearing you.
Sorry,
okay.
I was muted.
Yeah,
I was
can
muted.
hear now.
Sorry.
Okay.
It comes to what Shirishan always say, we have to keep the glass full. The training has to be constant. I mean, you do have the problem of the brain drain and all that. Thank you very much, and I hope we get back. I'm trying to save some time in the end for additional questions which are coming in, but let's take advantage that we are on time and invite our next speaker from FAO, Mr. Hamed.
Thank you.
Gunning, to provide his presentation, talking also about something which permeates, which I just mentioned. Really, it comes down to the food security issue and in there. So, Mr. Ahmed, if you want to just quickly introduce yourself and then begin your presentation, thank you very much.
Hello, would you please tell me if you have my voice?
I hear your voice, and we've got we have a slide up being shared. Perfect.
Okay, thank you. This is Hamed. Hi to everyone. Actually, I'm from the University of Tabriz, so just let me correct my affiliation here. I do research with University of Tabriz as a freelancer researcher. So this research that I'm gonna introduce you is one of our latest projects with University of Tabriz. It's the title is the recognition of different yield potentials among rain-fed wheat fields before harvest using remote sensing. So the research has recently done by the Department of Water Engineering at the University of Tabriz, and the outcomes are supposed to be useful for drought effect mitigation. Please, next slide. Using remote sensing, different methods have been developed to estimate crop yield, which allows the comparison of yield values in different pixels and in different growth periods. If the same crop is grown on different pixels, or if it is grown in one pixel but in different growth periods, the difference in the amount of yield can be considered as a yield gap. By identifying these reducing factors, and if measures are taken to mitigate them, the amount of yield gap that can be closed is called the scope of improvement. Therefore, any strategy for the food security goal can be based on estimating this scope of improvement and setting a sort of practices to achieve it. Next slide, please. Determination of the scope of improvement after harvest can provide useful information about agricultural fields, indicating that where the best practices must be focused to close the yield gap for the next season. But it will be more desirable if these areas can be recognized before harvest in an early time, when it is still possible to mitigate the gap by implementing quick actions such as supplementary irrigation and agricultural inputs. Easy and quick observation of any sign that can provide on-time information on occurrence of yield gap before harvest can be of utmost importance for crop production system. Then the two next steps can be followed as why productivity is low in these pixels and how it can be improved. So this research only provides a methodology for recognition stage, and the action stage can be recommended for next for future research. So here in this slide, as you can see, the idea came from this fact that wheat crop is very sensitive in its ancestors stage to yield reduction or reducing factors such as water stress. This research used the ancestors stage of the rain-fed wheat as a pre-harvest stage to detect an early and easy sign using remote sensing to predict relatively high productive and low productive pixels. It was investigated if evapotranspiration in a wheat pixel in the ancestors stage is less than the ET with the highest frequency in a plane at the same time, then it is a sign of relative yield gap. In another word, if ET in the ancestors stage is less than a threshold value, then the yield gap can be expected. Next slide, please. Well, to conduct this research and to test this hypothesis, some steps have been designed to accomplish relying on remote sensing methods. Due to lack of equipment such as eddy covariance towers or dissymmetric data in this study area, different validation steps such as surveying, use of pre-validated models and census data were embedded in the process. The steps are as follow, as you can see here in this slide. The first step is beat area mapping using elimination process of non-beat pixels verified by surveyed plots and census data. This step is something that's new for this research, and we will talk about it in the next slide a bit more. The second step is estimation of actual evapotranspiration at the ancestors stage using Sebal algorithm verified by Elgamanov-Holder method and mod 16A2 products. The third step is determination of evapotranspiration threshold value using frequency analysis and verified by Iranian National Water Document. The fourth step is recognition of high and low productive pixels by classifying them using the threshold value, ET threshold value. And the fifth step is the estimation of yield values using LUE model verified by provincial census data on yield. And the last step is determination of yield gap between the two classes by subtracting the values. And here in this step, the classification would be verified if the yield gap was considerable between the two classes. Next slide, please. Well, here is a brief summary of methods that we used in this research. The first one is the Sebal, or the Land Surface Energy Balance algorithm. Is a robust method for estimating actual evapotranspiration, while the application of this method for rain-fed wheat in our case study was verified by comparing the Sebal results with Elgamanov-Holder method results. The Elgamanov-Holder method is based on Faupemman-Montis method, while it uses precipitation and soil data to simulate the real situation and have been previously verified for Iran arid and semi-arid climate. The next method is the light use efficiency model, which is used for calculating yield values. It is based on Montis theory and relates the plant dry matter to absorb photosynthetically active radiation and the light use efficiency. Yield can be approximated as the summation of accumulated dry matter production multiplying by required coefficients in this method. I skipped the details as these methods are very famous enough to find information about them, but some extra description on the introduction, on the introduced method in this research for wheat area mapping. As you can see here in this slide, the method is fully rely on optical remote sensing, then appropriate for arid and semi-arid climate regions with low cloud coverage. The method contains of two major processes. The first major In the first major, the wheat area map was produced in 250-meter spatial resolution using MODIS images, and in the next major, the resolution increased to 13-meter using Landsat 8 bands. In the first major, wheat standard NDVI trend was produced using MODIS NDVI values on surveyed wheat plots. Having this trend on the table, the NDVI values of each pixel is observed during the wheat growth season, and at any stage, violations from this trend leads to elimination of pixels from the rest of process. So at the end, only wheat pixels with 250-meter spatial resolution remained. While in the second major, after producing 250-meter map, this map is used as a training data for supervised classification models on Landsat 8 images. The output of the classification contains all possible 30-meter pixels that can be considered as wheat pixels, knowing that there are some impurities. To remove these impurities, NDVI is calculated on 3 Landsat 8 images in descending arm of the wheat NDVI time series. For all the detected 13-meter pixels, the descending trend of NDVI is tested and violating pixels are removed to achieve the pure 13-meter wheat map from Landsat 8 images. Next slide, please. Here, you can see the wheat area mapping algorithm as a part of the high-low productive area mapping process, much more in detail. So if you want to see more details, you can refer to the paper. Next slide, please. Well, here, let's just take a quick look at the main results. The top left corner shows the location of a study area in the northwest of Iran. It's Ahar County. Then in the right-hand side, in the top left, it's a 250-meter wheat area map from MODIS. And in the opposite side, bottom right, is the 13-meter wheat area map from Landsat 8. In between, we have impure wheat areas from supervised classification methods in the top right, and in the bottom left, NDVI images from Landsat 8 corresponding to day of year in descending arm of the NDVI trend. So we almost mapped 37,000 hectares of wheat areas, showed 20% difference with census data. The calculated statistics for accuracy assessment were all in acceptable range. Next slide, please. And here in the left side, the frequency analysis of evapotranspiration values in ANSYS stage is shown, indicated that the most frequent amount of actual evapotranspiration values among wheat fields is in a range between 2 and 3 millimeter per day. The lowest value in the range, 2 millimeter per day, considered as the threshold value. This was supposed to be the required value if the crop in a pixel wants to be as productive as other pixels. To see if the classification based on this threshold value was successful or not in detecting low and high productive pixels, the difference between calculated yield values in two classes was calculated. According to the table, the mean yield value in high productive class was almost 800 kilogram per hectare, while it was 500 kilogram per hectare in low productive classes. This means that there is almost amount of 50% of yield gap between these two classes. And for sure, this study was only kind of a start, but as it seems, there must be other signs that can be used before harvest to predict yield, and hopefully any funding on this kind of research can be returned even after the current cropping season. Thank you everyone for listening to my presentation.
Thank you very much for the presentation. It gave me some thoughts. Also took me back to when I first learned about NDVI. A couple of follow-up questions. There is one question in the chat, which I'm sure you can address quickly. What is the emphasis stage? But before that, you mentioned that you basically did a research on 37,000 hectares, and basically coming within a range of the 20% of the census data. I think the big advantage about remote sensing is that you can actually do things remotely than actually having to gather that. So I'm wondering whether this research will lead to a further increase of remotely sensed data to do crop estimation. That's the second question, second consideration. And the third question, I noticed the yield gap, which you mentioned. And is there any further research, perhaps, to try to identify the causes of the yield gaps between areas? I mean, if you put in other variables with that. So basically, just as a follow-up, you have a couple of minutes to pursue this. What is the emphasis stage? Will remote sense data be used now instead of the census data? And how can you? What are the considerations on the yield gap? Back to you.
Yeah, thank you. In terms of the first question, the ancestors stage is maybe we can say the flowering stage of the wheat. So in one of the slides, I've shown the wheat NDVI time series, and I put the different wheat growing stages on that NDVI time series. So it is, as I said, equal or corresponding with the flowering stage, where wheat crop is very sensitive in terms of water stress. So if we can detect this sign before harvest that the wheat is under water stress in this stage, then maybe with quick supplementary irrigation or other emergency actions, we can prevent the yield reduction before harvest as much as it is possible. I think it's much more better than doing nothing for this. And about your second question, would you please repeat your second question? I couldn't understand it very well.
You mentioned you covered 37,000 hectares and you came up with a figure close to the census data. Do you think now you'll be using more remote census data for crop estimation instead of census data?
Yes, we to verify our research in terms of wheat area mapping, we used both census data and also surveyed wheat plots. So we kind of assured that our presented methodology works well, because as you know, even census data maybe have some errors, internal errors. So we can't say that all the census data will be fully reliable in this case. But we use both the census data along with statistical parameters to verify our methodology, and we believe that remote sensing data in this case can be used for the future studies. And about your last question,
yield gap. Did you have any considerations about the yield gap? Can remote sensing explore that? Probably has to do with water then.
Yeah. As I said, this research is mainly on recognition part. So the detection of the reasons must be postponed for future research to see. Now we know that where is the gap, but we should get into more detail, maybe with some even field studies. We need to see what is the problem. If it refers back to the soil, if it refers back to the lack of water or water stress, or if it is only comes from management problems at agricultural, for example, inputs or that sort of things. So these are the things that must be.
Okay. Thank you very much. We better move on. We've delayed a couple of minutes here.
After this research.
We've delayed a couple of minutes. I think we're keeping the time well, and I appreciate that everybody's kept their time. We have another presentation now, which in a way is going to also focus on food security, from Suhail Ahmed from the Pakistan Center for Advanced Studies. Suhail, I believe it's you that will be presenting. You have the floor. All over to you. Thank you very much. I'm not hearing anything.
Hello.
Have you unmuted yourself?
Hello. Are you hearing?
Now we can hear you. Welcome. Thank you very much.
Yeah. Yeah. Hello. I am Sohail Ahmed from Pakistan. I am working on estimation of water consumption and wheat crop water productivity in the Shikarpur district of Sindh by using the remote sensing technology. I worked along with Dr. Arjuman Zaidi in US Pakistan Center for Advanced Studies in Water, Mehran University, Jamshoro, Pakistan. During my master's studies, I worked on this topic as a class project with Dr. Arjuman Zaidi. Next, please. So water scarcity is increasing globally, as we all know that climate is changing, and recently IPCC 6 assessment report told us that there is worse conditions in the future, and so the water scarcity is also increasing globally, whereas the growing population requires more water for their food production. Here in Pakistan is also the same situation. Water scarcity is increasing and the population is increasing as well. So to understand the food-water relationship and excess water use efficiency and estimation of crop water productivity is essential. So for completing the demands of the food, we have to understand the crop water productivity. So crop water productivity actually is a relationship between the water used and the crop yield, or we can say that crop yield per accumulated actual evapotranspiration. Next, please. So the study area is in the province of Sindh. So Shikarpur district is situated in upper part of the Sindh, which is relatively hotter than the lower part of the Sindh. So the evapotranspiration is high in these parts. So we studied on crop water productivity of wheat crop, which is a Rabi season cash crop from this province. So Shikarpur district is situated in Upper Sindh. There is Indus River in between this province. So there are so many canal command areas. The district which I worked on is in the canal command area of Begadi. It's known as the Begadi Canal Command Area. Next, please. So wheat crop in Shikarpur, the district which I chose for the study is Shikarpur, and the wheat crop in this area, the total area of this wheat in this district is 36,007 hectares, with production of 1,623 metric tons production during this year 2013 and 40, according to the Bureau of Statistics 2017 report of this statistics. Next, please. So the problem statement is that some of the challenges to Pakistan's water and food security are increasing. So as water demand and decreasing water availability due to the fast growing population. As the population is increasing, the food demand is also increasing, and the crop water productivity in our country is less than the other countries which are using the technologies in their irrigation system. But here we still use inefficient irrigation practices and lack of implementation of policies. So that's why the crop water productivity is lower than the other countries. In such conditions, the knowledge of groundwater productivity is necessary for managing water resources and food production in the country. Next, please. So the data sets which I used is the satellite data set of ETRF from November 1, 2017 to April 10, 2018, and which is downloaded from double flux. Double flux is actually a earth engine evapotranspiration flux, which gave us potential evapotranspiration of the surface of the earth, and the other data which I used is the wheat crop mask, which was acquired from SUPARCO, Space and Upper Atmosphere Research Commission of Pakistan. This is a project of FAO and the United Nations Agriculture Department. They worked on this project to make the wheat crop mask and other crops mask for the whole Pakistan. So I used this data for crop mask. Next, please. And all other secondary data was collected from the literature review from different sources and reports which was published during these years. Next, please. Next. So the important part of the presentation is methodology. So first of all, estimation of ETRF. ETRF represents ET as a fraction of reference. In double flux, ETR is calculated by using the tall alpha reference as defined with the ASC standardized Penman-Mentuit equation. So the ETRF is calculated from the double flux, which gave us the potential evapotranspiration, which was calculated using this standard method or Penman-Mentuit method, which is a famous and more reliable method for calculating evapotranspiration. And the second is estimation of reference ET. As I told you before, that reference ET is obtained from the literature review and the other reports which was published during this period. The ET is taken from this paper, and they use the same method, Penman-Mentuit method, to calculate the reference evapotranspiration of all canal command areas of Indus Basin. So the reference ET values in the Rabi season are shown in the table 1 for Shikarpur district. So this is the reference evapotranspiration values in mm per month. In November it's 92 mm, and in December, as the temperature lowers in the area, the evapotranspiration is less, and then the temperature increases, the evapotranspiration per mm is also increases. Next, please. So the estimation of ET, now we have to calculate the actual evapotranspiration. Equation number 2 suggests how we calculated the actual evapotranspiration. Equation to estimate actual evapotranspiration per day. ETRF is multiplied with ET per day and number of days according to table number 2. This is the wheat stages in Upper Sindh. There are total four stages: initial, crop development, mid and late seasons. So these are the days, and this is the date which I worked on during the project. So after finally calculation of actual evapotranspiration, crop water productivity is calculated in kilogram per meter cube by using this formula. Yield which I get from the literature review, and the total area into evapotranspiration. So the crop water productivity is calculated by using this formula. Next, please. So the results and discussion. The average crop water productivity of Shikarpur district, which is situated in Begadi Canal Command area, was 0.81 kilogram per meter cube in the area 2017 and 18, with an area and production of 36,007 hectares and 1,623 metric tons respectively. The actual evapotranspiration which I was calculated is in initial stage is 29.44, then crop development, and then mid-season. So the highest evapotranspiration is in the mid-season, as the water consumed by the plant is greater than the other stages, and also the evapotranspiration due to high temperature, so its evapotranspiration is also increases. So this entire actual evapotranspiration was put in the that formula of groundwater productivity, and then we calculated this 0.81 kilogram per meter cube groundwater productivity in the area of the year 2017 and 18. Next, please. The reported groundwater productivity of wheat in Sindh is 0.32 to 1.088. According to the literature review, the groundwater productivity of wheat in the province is limits it to 0.32 to 1.088 kilogram per meter cube, which is lower than the Punjab groundwater productivity of wheat due to waterlogging and salinity problems. In Sindh province, which is a lower riparian, and also the plane is the plane the earth is plane, so the groundwater so the salinity and waterlogging is high in this province. That's why the groundwater productivity in the Sindh province is lower than the Punjab and upper provinces of the country. Next, please. So this is the satellite images of actual evapotranspiration of different stages. This is the initial stage, and this is the mid stage, which is a high evapotranspiration rate in this stage, and then the crop development and the late stage. So this is the entire season actual evapotranspiration of the entire season in remote by using the remote sensing technology and others. Next, please. So the conclusion of a study suggests that the study results summarizes that the estimation of actual evapotranspiration is vital for the management of irrigation, water, and crop stress conditions. The remote sensing techniques used for calculating actual evapotranspiration in this study are more efficient than the other conventional field-based methods. Also, the availability of the data is affordable to all the users. So the remote sensing data is easily available, and everyone can work on that data. So the conclusion suggests that the remote sensing technology gave good results and also easily available for working. Next, please. Thank you so much. These are the references. Thank you so much for listening.
Thank you very much for the presentation. Building on the previous presentation and perhaps showing one of the biggest values we have of geospatial technology, which is in the area of food as a whole. And it's interesting. We don't have any questions, but we do have people asking to share the presentation, of course. And of course, I'm sharing the email. I think one of the big advantages of a workshop like this is we can actually meet each other and build relationship. What I thought was interesting in the end, you said that the data now is freely available, and I remember it hasn't always been that case. But let me correct myself. You said the data is available. So you're using data over the internet, free data, right?
No, it's I said it's easily available.
Easily available. Yeah. Okay.
Yeah.
Perfect. Thank you. If we have time in the end and the questions come in, I will get back to the speakers with additional questions. But in the benefit of time, we're a few minutes late. I'd like to go on to our next presenter, Mohammed Farouk from Pakistan. He actually leads the UN Spider Regional Support Office. It's interesting because when UN Spider began, when it was established by the member states, we had 3 countries which came in: Germany, Austria, and China, who actually wanted to host Spider, and that's why UN Spider actually has 3 offices, because we got an office in Beijing, an office in Bonn, and an office in Vienna. But we had a number of countries which didn't want to host, but wanted to support in some way. And then that's why we have the regional support offices, in Pakistan being one of them, Nigeria being the other one, and ensuring that we have all the regional expertise available to the neighboring countries. And this, I think, is one of the things that has worked tremendously well, is you actually have these regional support offices providing a much closer support to the needs of the country. So I'm happy to have today Mohammed Farouk from the Regional Support Office in Pakistan talking about flood hazard assessment. So over to you, you have the floor.
Thank you very much, Mr. Javed. Thank you, UN Spider, for giving me this opportunity. And good noon to everybody. It's noon in Pakistan. As already Mr. David mentioned, that I'm representing the UN Spider Park RSO actually. I work for SUPARCO, the National Space Agency, and in addition, I'm looking for the space-based disaster management section over here for the last 6 years. And we have a very active contribution towards the SPIDER programs in the last few years, keeping me our experience in the field of the disaster management. Next one, please. Should I share my own screen? Okay, this is the agenda. A brief about just our RSO office, then background, why I'm talking about the probabilistic flood hazard assessment. And then another important component, there are two subcomponents, the flood frequency analysis, and the second one is the modeling aspect. And finally, I will conclude. Next, please. Space Application Center for Response in Emergency and Disaster, we call it SACRET. This is the UN Spider Park RSO inside the umbrella of the SUPARCO. We provide the space-based support to the national and provincial disaster management agencies and the event of the natural disasters. That includes the rapid mapping, rapid damage assessment, detailed damage assessments, and even now we are focusing the shift towards the pre-disaster activities to take the mitigation measures to help the decision maker to divert funds to this area. We do also provide support to the regional countries whenever there is an event under the SPIDER umbrella. So our email contact, and we do maintain a disaster watch. We provide the near real-time support to our users through this platform. We call it disaster watch, which can be accessed at the disasterwatch.sgs.suparco.gov.pk. Next, please. This the canvas of our previous experience in this field of the space-based disaster management that we had over the last almost 2 decades. We were unfortunately struck by 2 major events. The one in the 2005, the earthquake 2005, Kashmir earthquake, and then second, the big event, the flood 2010 in the 2010. Similarly, we had an avalanche in the northern areas. We lost precious lives of around more than 100 our soldiers. They were deployed over there, and then we have the cyclone Pat in the south, and then we have the drought, and then we have the landslide. So we have a landscape which actually witness to the many of the disasters that happens to these regions. Next, please. Next one. One more. Okay, so the background, why I'm here today and why I want to push the idea for the probabilistic flood hazard assessment. We had a very unfortunate event in the 2010. That was the 80 years event that struck Pakistan, and that originated from the north of the Pakistan in the Indus Basin and partially in the Jhelum and Chenab Basin, and that more or less inundated 20% of the Pakistan main agriculture fields and urban areas, more or less, and that we have huge losses in the shape of the economic, around $14 billion, and similarly we lost around more than 1,000 precious lives in these events. On the right side, you can see these are the pictures, the original pictures. The top right corner actually shows that even in the Swat Valley, you can see the speed and the turbulence in the waters. In the south, this is then the spread of the flood action again in Swat Valley, but that is in the plain areas. So that's the major reason which actually push us to think about the flood hazard assessment so that we can lessen the impact of these events in the futures. Next, please. The most important, since 2015, globally also and on a national level in Pakistan as well, there is a shift from the reactionary approach to the proactive approach. I will just refer to these three global agendas: the SENDAI Framework 2015-30. Priority 1 and priority 4 are actually the areas where we have the active role of the space-based technologies like remote sensing, GIS, and other. So what was the first one? Understanding the disaster risk. So that is only possible if we look for the hazard assessments. Similarly, enhancing disaster preparedness for effective response and to build back better in the recovery, rehabilitation, reconstruction. The second major component is the COP21, the climate change agreement. The Article 8 actually is the main article that actually give importance to the areas which can avert, minimize, and address losses and damage associated with the adverse effect of the climate change, and including the extreme weather events and slow onset events, and the role of the sustainable development in reducing the risk of loss and damages. Similarly, there is another global agenda which is called Sustainable Development Goal. SDG 13 is again the most relevant with us, which actually urge that take action to combat climate change and its impact. Again, the major challenge is to reduce the annual losses against the earthquake, tsunami, tropical cyclone, flooding, etc. So that was the major three agendas, global agendas. Finally, keeping in view this global agenda, we are part of the three agenda, and we have already ratified these three. So we have a national disaster management plan based on these three global agenda and as well as on our national priorities, which runs from 2015 until 2030. Next, please. Next slide. Okay, so I will just present a probabilistic flood case study right now, so which focus on the flood hazard modeling of the river Indus and its 5 major tributaries on the east and 2 tributaries on the western side. Next, please. This is the overall approach. We use the space-based data set like the elevation models. We use the land use, land cover to assess the manning values and to check for the calibration parameters. Similarly, we also use the geometric data, and in addition to that, we use satellite imagery for backgraph information and for the exposure assessment. In addition to that, we have also adopted the non-hydrographs for the model validation and calibrations. So finally, when model is calibrated and validated, we have the flood extent, flood depth, and flood velocity and flood duration, which are being used for the flood risk assessment on the national level, which is we are currently doing on a national levels. Next slide, please. To talk about the probabilistics, this means this is a two-step process. In the first step, you have to assess the long-term annual peak observed data so that you can estimate the probabilistic return periods like 5, 10, 20, 50, 30, 100 years. So the minimum recommended limit is actually 30 to 40 years annual peak discharge data is required if you want to assess the probabilistic flood for 100 years. So if your target is to assess more than 100 years, so it's better to have data of 50 or beyond that years that you can help. That can help you. Okay, then the tools that we have in our hands, we have used the Hack SSP, which is again an open source. Then there is another tool, Easy Fit. One of the demo version is available. You can exploit it. Similarly, if you have very good command in Excel, then we can use the Excel-based log PSN3 calculator, and there are some online calculator LP3 and GB which can be used for the estimation of the flood frequency analysis, which in the return give you the magnitude and the frequency of the probabilistic events. Next, please. I'm still at the flood frequency assessment slide. Okay, so this slide shows the return periods for the river enders that we actually estimated using the flood frequency analysis techniques. So the Tabela, this is in the up regions and in the north, and as we go toward the right side, the magnitude increases, and that is logical because then we have more tributaries on the left and right. And at the Guddu and Saka, this is a peak. But usually at the Guddu and Saka, we have major canal networks. And so that's why until the Kurti, then there is a bit reduction in the peak because the water is diverted on the left and right. And again, there is also it's a long river, more than almost 2,000 kilometers. So there is a one component is the river transpirations. Next, please. I'm still on the same slide. Okay, just a brief about the flood models. There are two types of the models which are used globally, 1D and 2D. Simply speaking, 1D model can model that can solve those flood modeling problems where flow is confined in a single direction, that is in the flow directions, and there is no lateral flows. So, so the 1D model which are available, there is a HECRAS 1D, which is a free via, and then there is a mic one, which is a paid version. This is the two commonly used, but there are a few more also. Similarly, the 2D model is suit to those flood problems where we have a two-dimensional flows, major flow along the rivers flow direction, and we do have the lateral flows. So this problem cannot be solved using just a 1D model. So the better option is then the 2D flood model. And again, the HECRAS 2D is the best option. And then we have Mike 21, and then we have the SOBAC. There is a RRI from UNESCO ICHAM, etc. And sometimes we do need a 1D, 2D model approach to accurately assess the flood issues. So again, in this case, we have the HECRAS 1D, 2D, and Mike 21 to solve this problem. Next, please. So this does the HECRAS 2D model capability, which can model 1D and 2D problems, and it can also combine 1D, 2D unsteady flow routings. The main equation behind the scene is actually the 2D Saint-Venant equation and 2D diffusive wave equation. These are the two options we use. Or you can simply say on the back-end side is actually the law of conservation of momentum and law of conservation of energy that actually the flood model adopt for the computation of the flood events. Next, please. In our case, these are the data set that we adopted for this modeling approach. We acquired the WorldDAM 12 meter because we want to have an accurate level of mapping, because our focus is to use these data as a base for the insurance industry. So that's why we opted for a paid DSM instead of the SRTM. So for the major river courses which are highlighted in the orange, we have used the WorldDAM from the Airbus. Then we use the spot satellite imagery that we acquire at our own stations. Then we have the national land cover, the Chow-Manning table, which is the standard table in the manual of the hydrology, then the embankment data, the flood discharge hydrographs, historical flood extents and hydrographs that we use actually in our models. Next, please.
Mr. Farooq, one more minute, if you could
Okay.
converge.
So this was the exposure data set for the urban context as well. So we divided the city into the low-rise urban, high-rise urban, and is it someone, and then we converted the data into the 100 by 100 meter grids for the utility. Next, please. So this is the crop data that we use for the risk assessment. Next, please. This is the historical flood 20 extent based on the satellite observation, which was used for the validation of the flood model. Next, please. And these are the Manning parameters, calibration parameter that were actually used during the model calibration and validation. Next, please. This was the actual model simulated output for the calibration and validation, which is based on the flood 2010. Next, please. I'm still on the flood model slide. Okay, that's the validation mechanism. On the left side, we have the simulated flood extent. On the right side, we have the observed flood extent based on the satellite imaging, and we compare the extent, and then we assess, okay, how much accurate results we have by simulating the models. Next, please.
I really need to ask you to, if you could wrap up, because the 15 minutes have gone already.
Okay, just two slides and I will wrap up. No, these are the hydrographs, and that's the best fit shows actually that your model has actually reproduced the event in a very good manner. Just next, please. You can just straight away now goes to the conclusion slide. These are best practices we have already on the UN Spider, so everybody can access. So primarily, what I just want to convey the message that the probabilistic flood hazard assessment is actually is the need of hour, and it helps in the identification of the vulnerable communities against flood. And again, we then have a estimated potential stock of physical vulnerability, physical assets. And finally, it helps in decision makers in prioritizing the flood mitigation projects. And last point is this will give us a baseline for insurance industry. So thank you very much, David. I'm sorry I was a bit overstepped in the time. So if there is any question, then I'm available.
Stay there, because we do have, according to me, we've reached the 50 minutes of the talk. But I just want to know whether the next presenter is online. We can't find them. Mr. Mustafa Nouri, if you could confirm, we don't see you online, which, okay. Ms. Farooq, can I explore a couple of things you said? I mean, many things. In the beginning part of your presentation, the way you actually brought all the agendas together, and you said that the National Disaster Management Plan for Pakistan built on top of all the frameworks. And you even had a reference to Article 8. Article 8 of the Paris Agreement is very interesting because it talks about loss and damage. And if anyone reads Article 8, and you should, Article 8 is all about disaster risk management, disaster risk reduction. It's interesting. So there's a lot of work for the. So one question to you would be, and I've got two questions, would be, how did Pakistan manage to have a disaster management plan that considered all the frameworks? I mean, this is no small feat that you actually bring in climate change SDGs into the National Disaster Management Plan. So Pascal question that. And the other thing that interested me very much is you actually, when you talk about your probabilistic flood modeling, you're actually looking at an empirical curve of possible economic loss due to floods. And then you mentioned how the flood industry, how the insurance industry are so interested in that. And that comes to the risk transfer. So, you know, when I talked in the beginning about different risk strategies, one risk strategy as actually transfer the risk, and that's why insurance industries are so interested in these probabilistic models, because it provides an opportunity to for the insurance industry to transfer risk. So that's my two questions to you. One is, how did Pakistan manage to bring together all the agendas into the disaster management plan? And the second one is the involvement of the insurance industry in this study. Over to you, Christopher.
Oh, thank you, Mr. David. Actually, but this was really interesting. As I mentioned in the beginning, after the aftermath of flood 2010, there was a big discussion on the national level that we should now have a mechanism to cope with the disasters. Even we started earlier than our this global agenda. So we actually refined them later on after 20. Actually, we started in 2012. So our national disaster management plan, which put emphasis on the all. We did a feasibility study based on the historical event of probabilistic. What are the major natural disasters which actually happens in Pakistan, and what are their intensity, and what are the regions where they have major intensity in the past and in the futuristic approach. Then again, before that, we were already, we do have a climate change ministry at our federal level. They are already pushed forward for the mainstreaming of the climate change in the policies and decision making. So these two events, actually, the earthquake and flood 2010, that actually pushed the decision makers at the top that we should focus the shift from the reactive approach to the proactive approach. So actually, we started in 2012, the National Disaster Management Plan, and that was initially for 2012 to 2022, actually. And then later on, when these three global agenda came on, then we have refined them. So now there are 3 to 4 major components. We can just have a look on that on the National Disaster Management Authority NDMA website in Pakistan. They do have these documents on who are there, and the one thing which is most related with us, this is the multi-hazard vulnerability and risk assessment. And I think Pakistan is one of the few countries in this region. We have already took a lot of efforts towards this direction. We are looking into the multi-hazard assessments now. And so that's the reason. So that's why we then again in the recent report, Pakistan is the ranked 5th in the global climate vulnerable countries. So again, this is also a concern. Initially, it was a 7th as per the German reports. And finally, how we do have the risk industries. Again, just the event of flood 2010 have a setback for the government of around $14 billion. So then the thinking again start in the 2015, because from the 2010 till the 2015, we have a flood disaster every year. So this was almost for 5 years, we have witnessed major floods. So that the thinking start every year, the government spends money on the recovery, rehabilitation, and reconstruction costs. There should be a mechanism to transfer this load to the insurance industry. So then we have a pilot in Pakistan, and now the main project, we call it a national catastrophic model. We are undertaking it, and hopefully it will be ready in a year or so. That will be actually the baseline for the insurance industry, particularly for the crop, because our major rivers run through the crop field. So we have major losses over there. And again, due to the earthquake, we have very enormous losses in the north. I hope. No,
it's very interesting. I mean, and it fits in right into having a national strategy replicating the local strategies. I just want to confirm, Mr. Mustafa Nouri, we don't seem to have you online. If you are online, could you identify yourself? Well, I think we seem to have lost the last speaker, which is a pity, because I did see his presentation and they brought a very interesting perspective. We will have his presentation to share, but for some reason maybe he had a difficulty joining today, which gives us time for an additional question. And I see a question from joined to Hamed on the presentation Ahmed gave on food security. Ahmed, if you're still online, there's a question to you. If you could elaborate more about water management to cope with crop stress using the methodology you were using. It goes and it sort of builds on top of that question which I asked about the yield, the differences in yield. Are you still online? Ahmed, I see
yes,
you online.
I'm online, David.
If you want to elaborate a bit more on the question which Jainta said regarding using methodology to cope with water management to cope with crop stress.
Actually, thank you for the question. I want just to add a point that yes, this research can be helped to elaborate and enhance water management in the fields, especially in terms of rain feed fields, as we need to, especially if there is any possibility to supply supplementary irrigation, water stress in the flowering stage will be is very important. So I mean, this research can be combined with the deficit irrigation studies, and I think the ancestors stage or the flowering stage is one of the stages that can be emphasized in terms of deficit irrigation and water management. This window can be considered as a time period for applying supplementary irrigation, especially for the rain feed areas, if there are any facilities to do this. For example, sometimes we can use some water sources, especially water sources from rainwater, to do these kind of supplementary irrigations. Did I target your question?
The question, yes, I think you did well. And Jainta, please, you can follow up if you have any further questions. I noticed Sadek has a question also regarding the simulation software. I think that would be an opportunity. Can I ask the speakers to perhaps put on the video? We've actually got 8 minutes. By some miracle, we've reached the end. Well, not miracle, we've lost one speaker, that's it. But we managed it. If the speakers would like to have any final contribution to make, please take advantage. We got the 8 minutes. So I invite all speakers who are online with us, if they'd like to turn on their video and provide maybe a final input, a final reflection. I actually have a final reflection of the session, which is interesting, but I'll leave that to the end. So please, if anybody has a final reflection, Mr. Farouk, I see you got your video on. Funmilola, you came on momentarily. If you want to come on as well, Ahmed, if you want to turn on your video as well. So, any final words? Any reflection on this session? Notice how much we covered in this session. We had the 3 diverse topics, but they all focus around water as a system. Please, who would like to say something? Funmilola, please go ahead.
Yeah, I just want to say investment in people is not a waste. We need to invest in our people. You know, when you invest in knowledge, in capacity building, in education as regards space technology, you surely get it back. You surely get it back. So the government should invest in their citizens, in their people.
Definitely. It's a constant learning curve. Even for me now, I've come up with some very good ideas of things I have to go back and relearn with them. Ahmed, Farouk, any additional final thoughts?
I just would like to add a point that remote sensing is now, with remote sensing, we are now able to to identify and to recognize hot spots in different fields. For example, in the field of yield or yield gap, or in the field of flood and drought hot spots, then we can send the facilities and the measures and the best practices directly to that spot. And this is, I think, one of the best priority of remote sensing in comparison with other methods. Thank you.
So focus on people, ability to focus on hotspots. Farooq, any last words?
Mr. David, I would just say it's a really a need of our now that we should not look into the disaster as an individual. We have to look into the now integrated approach, the multi-hazard approach. And then again, we have to look a bit beyond from the local AOIs and local study areas, because this emerging phenomenon of the climate change, and again, the issue of this forced urbanization, which actually also create problems for the urban floodings actually then. So this my concern, that we now should focus on the multi-hazard approach, and then we should also give focus to the more detailed physical asset based on the satellite images, so that we can actually assess the stock which is at risk or which are vulnerable to the natural disasters. So that's my thank you.
A multi-hazard approach. So we're looking at people, hotspot, multi-hazard. It's interesting. We're looking, UNFCCC, they're looking at the National Adaptation Plans and 2030 vision, and how a systems approach could allow countries to have better national adaptation plans. I always find it difficult. The systems approach, meaning getting what we did today as a group, all these diverse topics, they have to come in because one relates to the other. And I think that's the big challenge. Thank you very much. It's been a very interesting session. Even more interesting, in my reflection, is perhaps a bit different in the sense that I go back to the first workshop we had of UN Spider 10, 12 years ago, where we would have JICA, ISRO, German Aerospace Center giving presentations and saying how important their satellite imagery was. Notice that we've actually got today academics and practitioners coming with real cases. So from that perspective, SPIDER has gone beyond what was initially planned, and space agencies were pushing through COPUS the need to get countries to use space technology, where we're actually now, we're still a bunch of experts, but at least we're the experts working with the communities. So there's been a lot happening. What is a step further is when everyday people start using it as well, when people have a Google Earth engine on their mobiles and they're able to come up with the decisions without actually knowing they're using the space technology. And I think we're half a step towards that. So thank you very much. I really appreciate having you had this opportunity of this reflection. I do hope that that the connections we make today, and people will be contacting us, that we can actually build networks and do more with what we're doing. Particularly, the world is at a critical point. I mean, I said in the beginning, the first thing, we're at the decade of action. It's the last decade we as humanity have to be able to have something in place to make sure we reach 2030 in a better shape than when we began 2020. And with that, I'd like to pass back to the organizers, and thank you very much, everyone. Cherish, all yours.
Thank you, David. Wonderful moderation, and time management was also excellent. And thank you all speakers for bringing excellent research experience. And I see a lot of other questions coming up now. If you'd like, take time to just answer those in the chat. I see participants are really curious. That shows success of this session. And special thanks to David for keeping up this session way alive. So thank you, and looking forward, David, to use your expertise and your time more for this Spider. Thank you, and Fatima, you may have last word before close it. Yeah.
I personally wanted to appreciate Dr. Mr. Stevens for the great moderation presented, and it was a pleasant session we had. Thank you very much, Doctor. Thank you. Thank you for all speakers for this session. And I think we will continue our event in the afternoon at 14 p.m. Local Tehran time. Thank you. Thank you.
Thank you all. Wait, if you look all good, just wait for a minute. I take one screen capture. Thank you. This is nice. Okay. We are not closing the link, participants and speakers. The link will stay on and active, and please come back within less than an hour, and we'll be initiating next session, which is very interesting for establishing more coordination mechanism within Iran, so they can also benefit from discussion from international experts. So see you after short break.
Okay.
Stay online.
All right.
Yeah. Bye bye. Thank you very much.
Bye.